Okay, in this video we're going to talk about integers and properties of operations. So starting off, let's talk about what an integer is. An integer is just a positive and a negative number, so positive or negative number. So positive or negative values. It has to be a whole number though, so no decimals, and no fractions. So integers on a number line would be like 0, 1, 2, 3, 4, so on and so forth. But we can also go the other way, -1, -2, -3, so on and so forth forever. Okay, so in this lesson we're going to talk about adding and subtracting integers. So there's 3 good strategies for adding and subtracting integers. They kind of work with different parts of the brain. So for adding and subtracting integers. So the first one we're going to talk about is a manipulative. Okay. And the manipulative that we use for adding and subtracting integers are called 2 color counters. And it is just these red and blue. They're yellow. I said red and blue. Yellow and blue, excuse me. They're red on one side, yellow on the other. And so just a bag of those is all we need. Okay, so the yellow represents a positive number. So 1 yellow would be the number +1. 2 yellows would be +2, so on and so forth. And the way that we draw a yellow on our paper is a filled-in circle. Sorry. And then the red ones represent negative numbers. And the way we draw those on our paper is with an open circle. So that's one thing that you kind of have to get used to is this is with a filled-in circle, this is with an open circle. Okay? So the way that we do color counters is we make 0 pairs. Okay? So our goal here is to make 0 pairs, and a 0 pair is 1 red plus 1 yellow equals 0. So the number is 0. Because +1 and -1 equals 0. So together, those like cancel out, go away. That's a 0 pair. Okay, so this is the red one, -1 plus +1 equals 0. So that's kind of our goal here. So let's do a few problems with those color counters. So I'm going to do it with a manipulative first, and then I'm going to draw it on the paper. So if I wanted to show 2 plus 3. So 2 plus 3 with the color counters would be 2 yellows plus 3 yellows. Can I make any 0 pairs here? No, because I don't have any reds, so I have a total of 5. Okay, so 2 plus 3 is 5, and the picture is 2 yellows plus 3 yellows gives me a total of 5 yellows. Okay. For the second example, if I want to do subtraction, 5 minus 2 equals 3. Okay, so 5 minus 2, I'd have 5 yellows. If I was going to do this with color counters, I would think of the -2 as a -2. So -2, take away 2 would be 2 reds. Okay, so then I can make a 0 pair here. That's 0. So I'm going to push that over to the side because I don't need that anymore. That's a 0 pair. So this is 0 over here, and I'm left with 3 positives. I'm not sure why I put that right there. So 5 minus 2 gives me 3. And the picture of this, 5 yellows, 1, 2, 3, 4, 5, minus -2 or plus a -2. So plus 2 reds. I can make a 0 pair. So I'm going to show my 0 pair. by circling 2 together. So those go away, and I get 3 yellows, which is a positive 3. Okay, similarly, if I wanted to do -5 plus 2. So to show -5, I would do -5 with 5 reds, +2 with 2 yellows. Let's make 0 pairs. So 0 pair here, a 0 pair here. So this is 0. I'm left with 3 negatives. So my answer is -3. Okay, so picture 5 negatives plus 2 positives, so 2 yellows. I can make 2 0 pairs here. And so I get a total of 3 reds left, which is -3. Okay, so that's one way of thinking about negatives, is with making 0 pairs, and the picture with the manipulatives with the the red and the yellow, that really helps students see the 0 pairs. Another way of doing integers is to connect it with a real life example that they can understand. And one real life example that they can understand is with money. So think about the problem with money. So for the first problem we did, 2 plus 3 equals 5. I have $2. If I want to add 3 more, my mom gives me 3 more. So mom gives me $3. Now I have $5. Okay. If I wanted to do the example 5 minus 2 equals 3. I have $5. My mom took away 2. Or, yeah, my mom took away 2. I spent 2. However you want to think about that. So my mom took away $2. Or I spent it. Now I have 3. Okay, so those are pretty straightforward. Let's do the negatives now. What about if it was 5 plus -2 equals 3? So the 5, I have $5. The -2 is owing somebody something, right? I owe my friend 2. So after you pay your friend back, now I have 3. Okay. And then if I wanted to do -5 plus 2 is -3. So the -5, I owe my friend $5. My mom gave me $2. So after I pay my friend back with my $2, how much do I owe my friend? Well, I still owe $3. Okay, so students can understand things with money, like owing money, borrowing money. That helps explain the negatives. The last way is a number line. Okay, so most people think about it in terms of 0 pairs or a number line. It's good to do both, though, and to understand both, because some students are better with a number line, some students are better with the 0 pairs. So going through both. So a positive number or addition moves to the right on the number line, and a negative number or subtraction moves to the left on the number line. Okay, so for example, we've already done addition on the number line. If I wanted to do 2 plus 3 equals 5, on the number line I would start off with 2. So 0, 1, 2, 3, 4, 5, 6. So I would start off going up 2. So that's my 2. To go up 3 more now, 1, 2, 3. So that's 2 plus 3. I ended at the number 5. Okay, so addition, subtraction is the same thing. You go up your first number, go to the left backwards the other number to see what number you end at. Let's do some negatives. Negative 2 plus 5 equals 3. To do that problem, negative 2 on the number line. So my number line doesn't need to stop at 0, right? I'm going to keep on going both ways here. So let's put negative 1, negative 2, negative 3, negative 4, 1, 2, 3, 4. Okay, so starting at 0, go negative 2. So that means I need to go to the left 2. So that's negative 2. So I'm at negative 2 now. I want to go add 5 to it. Plus and positive means going to the right. So I'm going to go to the right 1, 2, 3, 4, 5. This is the plus 5 going to the right, and I ended at 3. Okay. And another example of that, if I did the negative 5 plus 2 equals 3. So again, on my number line, I got to go to negative 5 first. I got to draw that. Negative 5, 2, 3. So starting at 0, I'm going to go to negative 5, which means move left 5. And then I want to add 2 to it. So from 5, I'm going to go to the right 1, 2. And I ended at the number negative 3. That's supposed to be negative 3. Sorry, negative 5 plus 2 is negative 3. Okay, so there's 3 ways to show addition, subtraction with positive and negative numbers. Number line, using money, or using color counters. The last thing we're going to talk about is properties. So properties of operations. So of addition, subtraction, multiplication, and division. Okay, so the first property we want to talk about is the commutative property. So commutative property says I can move things around. When I'm adding, subtracting, no, not subtracting, when I'm doing operations, if it has the commutative property, the order that I do things in doesn't make a difference. So order does not matter. Some operations have some of these properties, some operations don't. So for example, addition, this property holds with addition because A plus B, is that the same thing as B plus A? We'll think about an example. 2 plus 3, is that the same thing as 3 plus 2? Yeah, they're both 5. So the commutative property holds for addition. It also holds for multiplication. Okay, A times B is the exact same thing as B times A. 3 times 2 is the exact same thing as 2 times 3. You get 6 either way. Okay, commutative property does not hold for subtraction or division because 5 minus 2 is not the same thing as 2 minus 5. Same thing with division. 5 divided by 2 is not the same thing as 2 divided by 5. Okay, so commutative only works for addition and subtraction. Nope, addition and multiplication. I'm having a hard time with the words today, sorry. Okay, so now let's talk about the associative property. Associative property means it doesn't matter like the grouping that I do here. Like which ones I associate first. So grouping does not matter. Okay, so let's see if this holds for addition. A plus B plus C. If I added A and B first, does it matter versus adding B and C first? Okay, so let's stick some numbers on there. 2 plus 3 plus 4. 2 plus 3 plus 4. So on the left-hand side, I'm adding 2 and 3 together first. to get 5 plus 4, which is 9. On the right-hand side, I'm adding the 3 and the 4 together first, so it's going to be 2 plus 7, which is also 9. So the associative property holds for addition. It also holds for multiplication, because for multiplication, A times B times C, it doesn't matter which one you multiply first. I can multiply the A and B first, or I can multiply the B and C first, and I get the same answer. For example, 2 times 3 times 4. If I do the 2 times 3 first, I get 6 times 4, which is 24. If I do the 3 and the 4 first, I get 2 times 12, which is also 24. Okay, so associative property holds for multiplication also. Last two things, we're going to talk about an identity element and then an inverse. Okay, so the identity element it is an element or like a number that when you do the operation with it, it doesn't change anything. Okay, so we have an identity element in addition, and in addition, the identity element is 0. And the reason why is when I add 0 to any number, does it change the number? No. So A plus 0 is the same thing as 0 plus A is just A. So 0 plus 9 is 0. I'm sorry, 0 plus 9 is 9. 9 plus 0 is 9. It didn't change the number when I add 0 to it. I also have one for multiplication. What would the identity for multiplication be? What can I multiply by to end up with the same number every time? Like the number I started with, it would just be 1. A times 1 is the same thing as 1 times A, which is just A. Okay, and then the inverse. The inverse is basically like the opposite of a number. It's basically the opposite. So it's the number that you add, subtract, multiply, divide by to get back to your identity. Okay, so it turns your number back into the identity. So it puts it back to the identity. So for addition, if I have a number, A, what do I need to add to it to end up with the identity? Well, the opposite for addition is a negative number. So A plus negative A equals my identity 0. This right here is my inverse. Okay, so for addition, the inverse is just a negative number. So for example, 2 plus negative 2 is 0. 0 is the identity, negative 2 is the inverse of positive 2. For multiplication, the inverse is actually the reciprocal. Okay, so for addition, the inverse is a negative. For multiplication, it's the reciprocal. For example, A times 1 over A gives me, multiply across the top, multiply across the bottom. So we get A divided by A, which is 1. So for example, 2 times 1/2 gives me 1. This is my inverse, and 1 is my identity. Okay, so those are important properties to know for integers with addition, subtraction, multiplication, division. Basically, addition and multiplication are the two that hold all these properties. Subtraction and division do not hold these properties.